So, what is a planar capacitor? So a lot of customers are using this because they want to increase the capacitance on their power and ground plane pair. And really simply what it is there's an upper conductor, a lower conductor, and it's separated by a dielectric material with a specific thickness and a specific dielectric constant. And the capacitance is directly related to the dielectric constant and that thickness. So if you here you have K and S. K is a constant, S is just the surface area. You have the dielectric constant on the top and the thickness on the bottom. So if you were to increase dielectric constant, you increase capacitance. If you were to decrease the thickness, you also increase capacitance. So that goes into the design of these types of laminates. Why would we design it the way that we do? And to show you a little bit more about that, here's really three types of these thin FaradFlex cores that we offer. The first, you could see here in orange, you have copper on the top and bottom, and here you have reinforcement plus resin. So in the center, we have a polymer reinforcement. That polymer reinforcement adds rigidity so that you can handle the printed circuit board through the shop and process it like a normal double-sided core. And then we have resin, which we use to bond the copper to that reinforcement. This top design gives very high electric strength. It's easiest to process, and it's the lowest material price. Um, we then have a second type of design, which are also used in PCBs, but also packages and modules. This is reinforcement, but with filler and resin. So we have the same reinforcement in the center. We take the resin that we had before and we put high dielectric constant fillers in it. And we use that to bond it to the polymer reinforcement. This provides higher capacitance because we're increasing the dielectric constant, but it still provides good dielectric strength, electric strength, and also it's easy to process as well because you're running it through the printed circuit board shop as a double-sided core, just like you would like an FR4, a thin off FR4. And then the final design is just resin plus filler with no reinforcement. And we see this mostly used in packages and modules, but it is used also in some printed circuit board designs. And what this allows us to do is get the highest possible capacitance. So you're removing the reinforcement layer, which is around a dielectric constant of 4, and you're packing it full of very high dielectric constant fillers, and you're reducing the thickness as much as you can. So this is where we can get down to 3 microns dielectric thickness. The only flip side of that is that it requires what we call single-sided processing because you need to always have a copper carrier that is that is unetched, that is carrying that resin and filler. So what customers usually do at the PCB shop is they will etch one side, process one side through print and etch, and then they laminate that to sub-lamination, and then afterwards you process the other side. So it requires more steps in the PCB process, but it also provides electrical properties that can't be achieved with the reinforcement.